This video will cover the part 3 questions, the 4-point short answer from the Geometry Review Day 3, numbers 34 and 33. They do go in the order in which I just said it because they are from 2 different exams, so I'm not crazy. I do know my numbers and the order in which they go. It's just the fact that we pulled them from 2 different exams. Flip it over. All right, number 34 down here at the bottom. P.S. If you missed the stuff up here at the top, you are welcome to go back to a video prior to this in which we talked about the 2-point short answer questions. All right, so looking at number 34, this was, I believe, from the June 2015 exam. It says in the diagram below, AC is congruent to DF, so that is marked for us. I'll just highlight it here so you can see. Points A, C, D, and F are collinear. That just means that they lie on the same line. Lie on the same line. Just like a coworker means you work at the same place, collinear means you work or lie on the same line. All right, let triangle D prime, E prime, F prime be the image of DEF after a translation, meaning a slide, along L, such that point D is mapped onto point A. So D gets moved all the way over here. Determine and state the coordinates of F prime. Explain your answer. So if D gets moved over here, then that means F has to get dragged along with it. And so does E. And so now we have this beautiful triangle. Mine's pretty ugly looking because I'm messy. But we have this triangle. We have E prime at the top. We know D prime is down here at A. And so that means F prime must be here. So F prime is located at C, and it's because of 2 things. Translations preserve distance and angle measure. Now, unfortunately, that's not enough to get you full credit. We have to say, and since AC was congruent to DF, with D mapping to A, then F must map to C. So I just pulled that out of the context of the question. AC congruent to DF, and D is mapped to A. So if D goes to A from that statement, then F must go to C. Okay, pretty simple, but you do have to have both parts to get full credit. The rubric is pretty picky on this question. Then the next question says that we have D prime, E prime, F prime, the double primes, be the image of D prime, E prime, F prime, the single primes, after a reflection over the line L. So I take this triangle up here in green and I reflect it over the line to become D double prime, E double prime, F double prime. Suppose that E double prime is located at B, which makes sense. E prime comes down here, becomes E double prime, and it's located at B. Is triangle DEF, the original, congruent to triangle ABC? So after we translate it and we reflect it, are they congruent? Explain your answer. So the answer here, hopefully you're recognizing, should be yes, because translations and reflections preserve, and again it's those 2 things, blank and blank, distance and angle measure. If we preserve distance and angle measure, then size never changes, meaning that they are congruent, the same size and same shape. Flip it over to C number 33, I believe. Triangle ABC has vertices A with x, 3, B with -3, -1, and C, -1, -4. So I'm going to take a second, pause the video, and plot B and C. I can't quite plot A, so we're just going to leave that one there. But plot B and C while you pause the video. Determine and state a value of x that would make the triangle ABC a right triangle. Justify why the triangle is a right triangle. So justify means that we're going to show math eventually. But in order to make it a right triangle, we need to think about what happens. What are properties of right triangles? Well, the obvious one is that they have a right angle. And right angles are formed out of perpendicular lines. And perpendicular lines have opposite reciprocal slopes. Meaning we take a slope and we flip it and negate it. I'm going to just write that off to the side because that's kind of important. Flip and negate. Okay, so now I'm going to find the slope of BC. Well, slope is represented by m, of course, y equals mx plus b. Slope of BC is the change in y over the change in x. So how far down are we going and how far to the right are we going? We're going down -3 and we're going to the right 2. So I'm going to make the perpendicular slope and flip the fraction and negate it. So this is going to be 2/3, and this will represent the slope of BA. Okay, so the slope of BA. So I'm going to go up from B, up 2, and over 3 plot a point. Up 2 over 3 plot a point, up 2 over 3 plot a point, up 2 over 3 plot a point. But I don't know where to stop. Right? I could keep going forever and ever and ever and really, truly make this a right triangle no matter where I connect to C. But that's not what I want to do, in fact. What I want to do is look back at the problem because it says that A should be at x, 3, meaning the y value should be at 3. So I need to stop somewhere where I see a point along this line, which is right here, point A. So then I connect, and I have a beautiful right triangle, but it does say to state the value of x. So A is at 3, 3, meaning that x is 3. Just so happen to be the same value as the y coordinate. Okay? When you're ready, come back to see part 4, the 6-point short answer question in the next video.